Hello everyone. In this video session, I'm going to explain part 224 of Java for Tester series, that is vector. So what is vector? What is vector? Vector is a predefined class in Java, and it is a child class of list interface which belongs to collections framework. Okay. So what is vector, guys? Vector is the predefined class in Java and it is a child class of the list interface. So list interface in Java has several childs, right? What are they? List interface in Java has several childs. One of them is ArrayList. Then we have linked list. And now we have vector. Vector is one of the child of the list interface. This is an interface, whereas vector is a class. Okay. Then interface and vector is a class. So let me show you visually. So this is a collections framework under which we have several interfaces and predefined classes in the hierarchy. Let's open this collection interface here, and when you open that, we got this list, set, and queue as a child interface of the collection interface. Under list interface, we have these several child classes known as ArrayList, linked list, and vector. So vector is one of the child classes of the list interface, which is a child interface of the collection and which belongs to the collections framework. Okay. So this is what is vector about. Fine. Now, how to use vector then? Okay. How to use vector and what exactly? How exactly we can use it and all. Let's find it out. So vector works similar to array list. Okay. Vector works similar to array list and with a minimal differences. Okay. There are few differences between array list and vector, guys. Let me show you. So array list, and on the right side we have vector. Okay, let's compare them so that you can understand how vector is different from the array list. The major difference between the array list and vector is vector methods or vector specific methods. When I say vector methods, vector specific methods, okay, are synchronized methods. Synchronized methods. Vector class has its own methods, and all those methods are synchronized methods. They are synchronized. What actually the synchronized means? Okay, synchronized means single threaded, guys. Okay, single thread, only single thread. Only single thread will share the resource. Let's say this is some resource. Okay, this is some vector specific resource, and using these methods, only one thread will access the resource. Okay, memory resource, memory object or resource, anything you can call. Okay, memory object resource will be accessed only by the single thread. Single thread. This is the reason vectors are slow in performance, guys. Okay, slow in performance and okay, slow in performance. Coming to the array list methods. Okay, array list methods or non-vector methods or non-synchronized. Okay, non-vector methods are non-synchronized. That means they are multi-threaded. Okay, these methods which doesn't belong to vector use multi-threads. Multi-threads. The same object resource, memory object resource. Okay, memory object resource will be accessed at a time by multiple threads. Okay, thread 1, thread 2, like this. Okay, irrespective of whether this resource is busy or free, multiple threads will access this resource at the same time to complete the task. To complete the task, multiple threads will access the resource in case of non-synchronized methods. Okay, ArrayList uses non-synchronized methods where multiple threads will access this resource. Whereas vector has only synchronized methods, guys. Vector specific methods are synchronized methods where only single thread. That's the reason vector methods are slow in performance, whereas non-vector methods, that is ArrayList methods or any other methods, are speed in performance. Because of multiple threads, they are speed in performance. Okay. So at a high level, this is the only difference, guys. This is the only difference. And one more difference, if I have to speak about, is vector is a legacy, old class. Legacy means old. Legacy class. It came from the old Java versions. Whereas array is a latest class. Okay. Vector is a legacy class. Okay. Vector is a legacy class, whereas ArrayList is a new one or something like that. Okay. Fine. Next thing is, what are other similarities? Now these are the differences, you can say. High level, if I have to explain about the differences, vector, the main difference between the vector and ArrayList is they work in the same manner, but vector methods are synchronized methods, whereas ArrayList methods are non-synchronized methods. Because of that, ArrayList is speed in performance and vector is slow in performance. And vector is the older class. Okay, it's there in Java from long time, whereas ArrayList it came after the vector. Okay, after the vector in the latest versions. Fine. Now let's find out more about this vector and ArrayList differences. That is, here similarities are also there, guys. Okay, there are a lot of similarities between this ArrayList and okay, similarities between ArrayList and vector. Okay, so what are the similarities between ArrayList and vector? Indexing is okay. Both use indexing only for storing the objects. ArrayList use indexing and vector use indexing. Okay, all the objects will be stored according to the index. Okay, first object will be stored at index 0, second object at index 1, like that. Similar to arrays. Okay, similar to arrays, ArrayList, vector also stores the objects as per the indexes. Okay, vector also stores the objects according to the indexes. Only difference is this synchronized methods. Okay, vector legacy class has the synchronized methods where only single thread will access the or share the memory, which results in slow in performance. That's the only difference. And one more difference we can, as you can see already, the difference has been explained here. This vector has its own methods, I am saying, right? Apart from the array list methods, vector has its own methods. Okay, vector has its own methods. That's the difference. Nothing more than we have to learn what are the different specific methods this particular vector has and how we have to use them. That I'm going to demonstrate, practically demonstrate soon. Okay. So for now, coming to the similarities, ArrayList has indexing, whereas vector is also indexing. Okay. ArrayList is a child class of the list interface. Okay, child of list interface. Even vector is also the child of the list interface. ArrayList is a grandchild of the collection interface. Even vector is also the grandchild of the collection interface. Okay, almost everything is same. Everything is same except vector specific methods, which are synchronized methods, which came from the legacy class vector. Okay, that's the only difference. Nothing more than that. So anything else? That's great. So now let's move on to practical mode case. Okay, hope you understood the difference and similarities between the ArrayList and vector at a high level, right? So now let's move on to the practical usage of the vector. Okay, how to use the vector? We have to say vector v is equal to new vector, I will say, and we have to create an object for the vector class. Over the mouse on the vector and say import vector from the java.util package. Now using this object reference of this vector, we can access the vector specific methods, which are synchronized methods, and also non-vector specific methods can also be accessed. That is because vector is a child class of the list interface and grandchild of the collection interface. That means the predefined methods of this collection interface and the predefined methods of this list interface can be accessed by vector also. Apart from this vector specific methods, these are all the different vector specific methods, okay, which belong to the vector only. Okay, apart from this, using the object reference of this vector, we can access the parent, grandparent collection interface methods and parent list interface methods also. Okay, similar to array list and linked list, we can access the grandparent interface methods and parent interface methods apart from the specific methods of the vector. Okay, fine. So let me show you a high level, like give you some high level usage of this object reference for accessing the grandparent and parent interface methods. Okay, before I explain you the vector specific methods, I'll show you whether this vector object reference can access the methods of the predefined methods of the collection interface and list interface, which are the grandparent and parent interfaces of the vector class. Okay, so v dot, you see all the things are coming as add method we can use, add index. This is from the collection interface. Add of object is from the collection interface, right? So I have to add object directly like this. v dot add at index, particular index. At index 1, I want to add, say, Varun. Okay, I can use this also. This one came from the list interface. You can see here, list interface, we have add of index object. Okay, I'm able to use with the vector object reference. Collection interface, we have this add object. Like that, we can use all these methods and all the methods here also. And we can even use a get method of the list interface for retrieving them. Okay, system.out.println v dot get of 1, if I say, it will retrieve this Varun and print. Okay, so if I run this, it will retrieve the 1 index 1 object, that is Varun. Okay, and also similar to array list, we can print the vector. Okay, how to print the vector? You just print this object reference, all the objects added to this vector will be printed. Okay, same thing that we used to do with the array list or linked list. Okay, you see both the objects got printed, both the objects in the vector got printed. So all these things are similarities, guys. These are all similarities. You can use the non-synchronized methods of the collection interface and list interface using the object reference of the vector. At the same time, using this object reference or of vector, we can use the specific methods which are related to the vector class only. What are the different methods which are specific to the vector class? Vector class comes with this predefined methods known as add element, remove all elements, remove element at elements, find element, last element, and size and elements. Let me practically demonstrate all these methods. Okay. V dot vector has for adding the objects, a vector has specific method known as add element. Okay. So instead of this add, which is coming from the previous, we can actually use add element. Okay, add element of Arun, I can say. Okay, vector specific methods. And apart from that, I'll add few more elements. Add element, and I will say 9 integer object 9. V dot add element. You can add heterogeneous objects, guys. Okay, that's not a problem. V dot add element 3.56 double object, boolean object, integer object, and string object. Like this, you can add different type of objects. So system.out.println, just to check whether all these objects have been added using the add element synchronized method of this vector class or not. Okay, so for that I will print this v object reference of this vector to see whether they got really added or not to the vector. You see they got added, guys. Arun followed by 9, true, and 3. Here you see insertion order is preserved. The similarities are coming back, right? Because indexing is there here and here. What are the advantages of indexing, guys? One is insertion order is preserved. Okay, first thing is insertion order is preserved. Second thing is duplicates are allowed, right? I kept on explaining about this insertion order preserving, duplicates are allowed, and null values are allowed. From array list and linked list, I explained all these things. Okay, you can refer to the previous videos, guys, array list and linked list, so that you can understand what exactly I am talking about. Okay, just because of this indexing, we are getting these benefits. Okay, here also insertion order is preserved. That means the way in which you added, when I printed, when I retrieved it or printed it, you see they got retrieved in the same manner. Arun 9 true 3.56. Okay, because insertion order is preserved because of the indexing. Similarly, duplicates also I can add. V dot add element. I can add Arun again. Okay, at the index 4, I guess I'm adding the Arun 0, 1, 2, 3, 4. At the index 0 already Arun is there, and at the index 4 also Arun is there. Okay, so duplicates are allowed because they are differentiated with the help of the indexing part. So these are the similarities, guys, between the array list and the vector. Okay, so you see Arun is added twice without any problem. Duplicate object is added twice. Okay, so insertion order is preserved, duplicates are allowed. You can even add the null values, null objects. If you don't want to add anything, you can, in place of the objects, you can add the null, guys. Null means nothing. At the index 5, I added null. Let's see whether it got added or not. Right click run as Java application. Null also got inserted without any problem. Okay, these are all the common similarities between the ArrayList, linked list, and vector, guys. Okay, because of the indexing, they behave in the same way. And apart from that, as I kept on explaining, this vector has its own specific methods, which are synchronized methods, where only single thread will be accessing this, sharing the resource or accessing the resource, which results in low performance. And vector is a legacy class. That's the only difference you have to understand, guys. Everything works same. Fine. Then coming to the add element, I am done. And for retrieving the elements, instead of the get method, this vector legacy class has its own method known as element it. Okay, instead of using this get method here, in the list we have this get of index method of the list interface, right? So similarly, vector also has its own method known as element it. Okay, synchronized method this is. So let's see that. So here I will say system.out.println list dot get of 3. Instead of get, I am going to use element. Sorry, it's not list, it's v, guys. In this case, we have used v dot element at. You see, instead of get index, we got element at index. Okay, I'm giving the index value as 3. So 0, 1, 2, 3. So double value, double object should be retrieved by this element at method. Okay, so you see 3.56 got retrieved as expected. Similarly, other method, let's go on. Let's use a remove. Okay, I will use v dot remove element. Okay, directly remove element. I have to provide the object, which element I want to remove, which object I want to remove. I want to remove this boolean object. Let's say true, I will give. Okay, this true object will be removed, guys. Okay, out of this all objects added to this vector, this true object will be removed using the remove element. Okay, so when I print, after removing, if I print v, you see, except this true, everything will be printed. So let's run this. Right click run as Java application. You see, except true, everything got printed, guys. Okay, Arun 9, true, 3.56, Arun null are there. Here, true is not there. Okay, it got removed. Similarly, we have another method for removing, guys. That is remove element 8. Okay, which uses index for removing. Instead of taking input as an object for removing it, okay, it takes this v dot remove element at. Okay, element at a particular index I want to remove. I want to remove an element at the index 3, let's say. Okay, 0, 1, 2, 3. 3.56 is there at this particular index 3. Okay, this element is going to be removed. If I print v after removing this element, which is our object which is available at the index 3, all the remaining objects will be printed except that 3.56, which is available at the index 3. You see, Arun 9, 3.56 is not there. It got removed by using this method. Okay, so next thing is we are done with all these things. Remove all elements. Remove all elements will clear all the elements, guys. Okay, if I say dot remove all elements, v dot remove all elements, this will remove all the objects from this vector. That means all the objects will be cleared, and when I print, after removing all the elements, if I print v, nothing will be printed, guys. Okay, every object will be removed, completely wiped out. Okay, something like this. And the next one is we are done with this side, and let's go with this side. First element, last element, size, and elements are left. Okay, so let me explain about that. So now we have all these objects added. Around 9 true, 3.56 around null is there. So in that, I want to get the first object, first element only. System.out.println, system.out.println, v dot get what is that first element. V dot first element is a method. Okay, synchronized method of the vector class. So if I say this, what is the first element out of all these objects, guys? This is the first, Arun is the first object, which is at the index 0, right? So let's run this and see whether we are getting the proper output. Yes, we are getting that. So now let's move to the next method, that is last element. Okay, system.out.println, system.out.println, v dot last element. Okay, last element. If I run this, right click run as Java application, you see, null is the last object. Okay, we added null at the end, so null got printed. Fine. Then size. So system.out.println v dot size. Okay, it will give you the size of the vector, guys. 0, 1, 2, 3, 4, 5. 5 should be the size. Okay, or 0, 1, 2, 3, 4. So 6, right? 6 elements are there. 6 objects are there. 1, 2, 3, 4, 5, 6. 6 should be printed. Let's see what will be the result. 6 should be printed here. The size of the vector is 6 here in this case. Yeah, 6 got printed. Next thing is elements. So guys, before I explain elements, let me take back. Okay, elements is the specific method of this vector class. And do we have such kind of methods in the collection and list interface? Yes, in collection we have something known as iterator. Okay, cursor methods, cursor class related stuff. This is okay. So what I mean to say is collection has this method known as iterator method. List interface has a method known as list iterator, which is an advanced version of this iterator method of this collection interface. Okay, this list iterator is an advanced version. Fine. And now coming to the vector, vector also has such kind of method known as elements. Okay. So iterator, list iterator, and coming to vector, it is elements. Coming to vector, it's elements. So let me explain about this elements now. So vector class, vector predefined class, which is a child class of the list interface, has a predefined method known as elements. Okay, and when you use this elements predefined method with the object reference of this vector class, it will return you. It will return you. What it will return, guys? It will return something called enumeration. Okay, enumeration. It's there somewhere here. Let's go to the other enumeration. It's also an interface, guys. Okay, it will return you the interface. Enumeration will be written. In case of iterator, which I already explained in the previous videos, we have this iterator, list iterator. Okay, this iterator belongs to the collection interface. Okay, this is a vector is a class here. I'm just comparing so that you will get a clarity on what exactly I'm trying to explain. List iterator belongs to the list interface like this. Okay, and the return type of the iterator is iterator interface. Okay, and the return type of this list iterator method is of this list iterator method belongs to the list interface. Okay, and its return type is list iterator is the interface. Okay, return type. So like this, coming to the vector, elements is a predefined method of the vector class and its return type is enumeration. Okay, so this enumeration has its own methods, guys. Coming to the iterator, it has its own methods like has next and next methods. Okay, as next and next are the predefined methods of the iterator interface. Coming to the list iterator, we have more advanced methods like along with this has next and next. Along with this has next. List iterator also has previous and previous methods. But coming to the enumeration, it has more elements. Okay, some methods like let me practically show you v dot elements I have to say. Okay, if I use v dot elements, it will return you what, guys? This elements method will return you what? It will return you enumeration interface. As you can see, hover the mouse on these elements and see enumeration is being returned, guys. Interface, enumeration interface. So I will say en is equal to, okay, and hover the mouse on this en and say create local variable. Enumeration en is equal to vn, v dot elements. Okay, so I have to use something like this. While en dot has more elements. So here it has more elements. This is one, and there is like next element something is there. Okay, while this enumeration has more elements, I say system dot out dot println en dot next element. Okay, next element. Here we have next element. So I'm not explaining much about these things, guys. Okay, because if you understand this ArrayList and linked list videos which I explained in the earlier videos, you will understand what I'm explaining about this vector here. Okay, so I'm not taking more, but these are the methods of the enumeration interface, guys, which you can use now. Okay, so now it will iterate through all these elements and print one by one. So how this will work, let me explain at a high level at least. Okay, so let's say these are the different objects we have inside the vector. how many are there, guys? 1, 2, 3, 4, 5, 6 should be there, right? Here we have 6. So in the first we have Arun. The second we have 9. And third, true we have. Then we have 3.56. Then we have again Arun. Then we have null, like this, okay? And this object reference, that is en, okay? Here I gave the object reference name as en, guys. You can give any name anyhow. And this en is pointing somewhere, okay? It's not pointing anywhere. It's like at this particular state now, okay? Visually, this is how we will understand, guys, okay? So while en has more elements, are there any elements in the vector? Yes, 1, 2, 3, 4, 5, 6 elements are there. This will return true, guys. This will return true because the vector has 6 elements, 6 objects, okay? Has more elements, that is 6 objects are there, so it will return true. We'll go inside that. Now it will say en dot next element. When it say en dot next element, this cursor will be pointing to this one. When immediately when you say next element, this cursor will come and point to the first object, okay? And you are printing that, and you are printing this object. So what will be done, guys? In the output, Arun will be printed first, okay? Then again the control will go to this condition, has more elements. Yes, 5 more elements are left, okay? So again true, again en dot next element. So when you say immediately when you say en dot next element, this cursor will come here. Now cursor is pointing to 9. So when you print that, 9 will be printed in the output. Similarly, the cursor will keep on moving. For every iteration, it will keep on moving, and all the elements will, and the vector, all the objects in the vector will be printed one after the other one, like this 3.56, and Arun, finally null. And after everything is printed, again when the control comes back here, has more elements, all the 6 are done. So there are no other elements. This will return false and will come out of the while loop, okay? So this is how, guys, we have to use the elements method, okay, which will return the enumeration object. Using the enumeration object, we'll get these 2 extra methods known as has more elements and next element, using which we can iterate through this objects of this vector. So when I run this code, you will see that all the objects of this vector will be printed, okay? Right click, run as Java application. Arun 9 true, 3.56 Arun null, okay? Like this, all the objects will be printed. So we are done with cursors also, guys. I already explained about iterator, list iterator with the ArrayList, and then enumeration I was able to explain with the vector also now, right? So fine. Enumeration and enumeration methods I explained. Enumeration methods are nothing but has more elements, and next elements are the methods, predefined methods of the enumeration interface. Okay, we have to use elements method of the vector class to return this object reference of this enumeration interface. And using that object reference, we can access this has more elements and next element. So guys, these are all the different methods which are specific to the vector. I demonstrated all the methods, guys. Okay, add element, remove elements, elements, first element, last element, size, and elements. Everything is covered. Along with this, synchronized methods which are specific to the vector, we can also use the non-synchronized methods of the collection interface and list interface using the object reference of this vector class also. Okay. So guys, what is the difference now, guys? At a high level, what is the difference now between the ArrayList and vector? Vector has its own methods, which are synchronized methods, where single threads will be accessing the resources. That's the reason the performance is slow. Coming to the ArrayList actually uses the non-synchronized methods for accessing the resources, and where performance is high. Okay, and vector is a legacy class, whereas ArrayList or linked list or ArrayList or linked list are the latest classes, whereas vector is a legacy class. These are all the only the differences. Apart from that, everything is similar between the ArrayList and vector, guys. Okay. So guys, that's all about the vector. And before I conclude, you can even use generics, guys. Generics concept I kept on explaining from the array list and linked list also. You can, because you are seeing some warning messages here, right? Yellow color warning messages. Still it is working, but you can actually add object here, okay? Because you are storing some heterogeneous objects, right? So different type of objects. So you can add object here, and you can put empty less than and greater than symbol. This will work, okay? If you only want to store string objects, so provide string class here, and you will get the compiler errors here, because you see these are not strings, guys. 9 is not a string, true is not a string, 3.5 is not a string, like this. If you provide only integers here, only integers value will be allowed. And when you try to provide any other type of objects like string objects or boolean or any other things, you are going to get the compiler errors. Okay. So these concepts I already explained as part of the array list and linked list. Just go back and watch those videos, guys, so that you will understand how to use the generics with the collection frameworks, class, and interfaces. Okay. So that's all about the vector, guys. We are done with the vector, and in the next video session, I'll continue with the next predefined class of the collections framework, that is stack. So somehow the stack is somewhere here under the collections framework. We have these things. Let's go back. So under collections framework, we have collection interface. Under collection interface, we have list, set, and queue. Under list, we have array list, linked list, vector. So we have stack here. Stack is the child class of the vector class, which I have just now explained in this video session, where vector is the child of the list interface. Okay. This particular stack predefined class, which is the child class of the vector class, I'm going to explain in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye.